So let's start with the next concept. So in this video we are going to see about activated sludge process. Okay. So up to now we have covered up to the primary sedimentation tank, or we say it in sewage treatment as primary clarifier. So once the sewage is passed through the primary clarifier, after the settling process, that is type 3 settling in primary clarifier, the sewage reaches for the next step, that is biological treatment. So in this also we have two categories, aerobic and anaerobic treatment. So first the sewage is treated with aerobic treatment. So we have seen this aerobic treatment is very fast process. Okay. So hence it is quickly treated with aerobic treatment, and after aerobic treatment, anaerobic treatment is given to the waste. So after the anaerobic treatment, what happens? The amount of end product that is produced, that is the volume of end product, is significantly low by anaerobic process. But this process is slow. Anyways, so let's concentrate on the video on this concept, that is activated sludge process. So let's give the heading, activated sludge process. So before starting this, let's write down a few important points. The first and the most important point is who developed this method. So it was developed by the scientist Arden and Lockett in 1914. So this method was developed in 1914, that is during the start of World War I. So before going to the main concept of activated sludge process, first you should know few basic things. Okay. So the basic things that are required is what is the role of microorganisms in decomposing, or we can say in decomposing the organic matter. So these microorganisms, this decompose, or we can say this oxidize the complex organic matter into simple and stable end products. See, these microorganisms, they eat this, or we can say in simple language, they eat this organic matter, and they convert, or the whatever the end products are there, they convert it into simple and stable end products. Now this organic matter, this acts as a food for microorganism. Now, can we measure this organic matter directly? Is there any test to determine the organic matter? No, there is no test to determine the organic matter directly. So this organic matter or the food, this is represented in terms of BOD. Okay. Whereas these microorganisms, we will see that in these microorganisms, we will denote it with MLSS. So what is MLSS, that we will see. For now, you just remember these two things, that the food is represented, or we can say the organic matter is represented by BOD, and microorganisms are represented by MLSS. Now, so this is the first concept that you should know. The second concept is what is the meaning of aerobic reaction, or what happens in aerobic reaction, because in this activated sludge process this thing is going to take place. So when we talk about aeration, or we can say aerobic reaction, in aerobic reaction, whatever the organic matter is there, so if you just write it here, complex organic matter, complex organic matter, so it reacts with microorganisms in presence of air. Okay, so that's why it is called as aerobic. So this reaction gives carbon dioxide plus NH3 plus water and plus some energy is released. Now, as we have seen, this complex organic matter, this acts as a food for microorganisms, and if this reaction is taking place in presence of oxygen, then it is called as aerobic reaction. Now this CO2 plus NH3 that we are seeing, this we are calling it as a simple and stable products. Okay, or this we will also call as, we can call it as biomass, or sometimes we'll call it as sludge. Okay, so these all things will represent the same thing only. So how this sludge or biomass this is produced? This is produced due to the reaction of organic matter with microorganisms in presence of oxygen. So these two things you should know first, and then we should go for the main activated sludge process. Now, starting with the main theory. So what happens in activated sludge process? So the diagram which you are seeing is the diagram for activated sludge process. Now, as you can see, there are two tanks which are present here. So this is tank number 1 and this is tank number 2. So this first tank is called as aeration tank. This is called as aeration tank. And the second tank, it is called as secondary sedimentation tank. Okay, so the aeration tank combined with secondary sedimentation tank is, this entire setup is called as activated sludge process. We'll see why it is called as activated sludge process in the subsequent time. Okay, now this sewage is coming from this side. So let's say we'll give some notations here. So this is the discharge Q and the BOD of influent sewage YI. Now this V stands for volume of aeration tank, and the X stands for MLSS concentration. This is an aeration tank. So what happens in aeration tank? So there are two things that happens in aeration tank. One thing is the mixing of water and the sludge which is taken back, and the second one is aerobic reaction. So once the sewage is taken to the aeration tank, there is some reaction which takes place here. We'll discuss that. After this, the sewage is taken, or we can say the sludge which is generated in this aeration tank, it is taken to the secondary sedimentation tank and slowly it settles. So whatever the sludge particles are there, so this sludge is settled here. See how this sludge is generated in the aeration tank. In the aeration tank, there is aerobic reaction which is taking place because we are supplying it oxygen. So the microorganisms which are present in the sewage, they oxidize the organic matter, or we can say they eat the organic matter as it is their food, and they convert this organic matter into simple and stable products that we are calling as sludge. Okay, so this sludge is then taken to the secondary sedimentation tank for settlement. Okay, now see this sludge, if I just draw it here, let's say this is a sludge particle. Now around this sludge particle there are microorganisms which are present here, or we can say these are living microorganisms. As they are living microorganisms, that means we can call it as active microorganisms. Okay, so these microorganisms plus the sludge which is there, so this inside yellow which you can see, this is a sludge particle which is covered with the living microorganisms. This entire thing is called it as, we call it as active sludge. Okay, we call this as active sludge. Now just focus here. In aeration tank there is there is decomposition of organic matter by using the microorganisms. That means, let's say these microorganisms will denote with M and organic matter will denote with F. So if the microorganisms are more, then the food will, what will happen to the food? The food will start decreasing quickly, because more microorganisms will eat the food more quickly. Same thing here. What is happening is that to increase the efficiency of this process, a certain amount of active sludge, just pay attention, this is the most important part in this. To increase the efficiency of activated sludge process, certain amount of sludge which is present in the secondary sedimentation tank, it is taken, or we can say it is recycled back to the aeration tank. Okay, so certain amount is recycled back into the aeration tank. As it is recycled back, or we can say as this active sludge is recycled back to the main aeration tank, we call this process as activated sludge process. Okay, so this is how the name has been derived. And why this is recycled back to the aeration tank? Why the certain amount of sludge is recycled? To increase the efficiency. How the efficiency will be increased? See, this sludge is already having some microorganisms which are in active state. Okay, so if we increase the number of microorganisms, in aeration tank, then the decomposition rate will increase, because more microorganisms are present and the food is limited. So there will be higher decomposition, we can say higher oxidation of organic matter. Okay, now let's summarize these points which we have seen up to now. So the first important point is microorganisms microorganisms chase food in aeration tank. Okay, so we can just visualize it as a buffet party. So you must have gone to many buffet parties now. So what happens in buffet party? So there is some food which is kept at certain places. Let's say this is noodles, this is Manchurian, and this is pizza. Okay, so in buffet party you have to go to the particular stall. Let's say I want to eat noodles, then I will go to the noodle stall and I will take it with myself, that is I will eat it myself. So microorganisms have to chase the food in aeration tank. So this process is also called as suspended suspended growth process. What is the meaning of the suspended growth process? So this suspended means microorganisms microorganisms are in suspension. See, in this aeration tank, whatever the microorganisms are there, these are present and sludge is also present. Okay, so they both are kept in suspension here, hence it is called as suspended growth process. Very important point. So in biological treatment, in biological treatment in biological treatment complex organic matter complex organic matter is converted into stable organic matter. Okay, and this stable organic matter This stable organic matter is then removed in secondary sedimentation tank. Secondary sedimentation tank. In this process, sewage and active sludge. So sewage and active sludge. So these both are brought in contact. Okay. So these both are brought in contact. Hence, it is called activated sludge process, because we are using here activated sludge. Okay. Now, see, sewage is present in the aeration tank initially. Sludge is produced, or we can say sludge is settled in the sedimentation tank, secondary sedimentation tank. When we are recycling certain amount of sludge back into the aeration tank, then this mixture of sewage and the sludge, this mixture is called as mixed liquor. Okay, so write down the mix of recycled sludge, mixed of recycled sludge and sewage in aeration tank is called as mixed liquor. Okay, so this term, now you should remember what is the meaning of this mixed liquor. It is a recycled sludge plus sewage in aeration tank. Okay, now in the first slide I have given you one term, that is MLSS. So this MLSS stands for mixed liquor, and SS means suspended solids. Mixed liquor, suspended solids. Now what is the use of this? So this is an index for measuring the, or we can say it is an index which gives us the mass of microorganisms. It gives an idea about mass of microorganisms in aeration tank. Okay, so let's go to the first slide to understand this. See, the main reaction is microorganisms plus complex organic matter gives the stable and simple end products. These microorganisms, this we are expressing in terms of MLSS. So whenever we will say MLSS, that means we are representing the microorganisms there. So this MLSS, it is nothing but it is an index for mass of microorganisms in aeration tank. Now this one point is important here. This MLSS, it is equal to MLVSS plus dead microorganism. Okay, so this MLSS, when we calculated, when we are saying MLSS, then this MLSS contains both MLVSS and dead microorganisms. Now what is this MLVSS? This MLVSS means living microorganisms. Living microorganisms, and it stands for mixed liquor. This V stands for volatile suspended solids. So as you can see, this MLVSS, it gives a better representation than MLVSS. Why? Because it only considers living microorganisms. See, in this process of activated sludge process, we only need the living microorganisms. These dead microorganisms are not much important to us. So hence MLVSS gives a better representation than MLSS. So this is all the theory points that will be required here. So in this diagram, activated sludge process, this all parameters we have to check. See, this is this in this chapter we can say this is a mainly this is a formula based. Okay, so there are a few formulas that we have to remember, and based on this only you can solve any problem from this. So basic idea you should get about activated sludge process, that it consists of two tanks. Aerobic reaction takes place. What happens in aerobic reaction? That is a conversion. Then why it is called as activated sludge process? So these points you should know first. Okay, now, so when the sewage is initially brought to aeration tank, there is aerobic reaction. Sludge is developed. That sludge is settled in the secondary sedimentation tank. To increase the efficiency of this process, some sludge is taken back to the aeration tank. Okay, so when it is taken back, so let's say the discharge is QU. So I'm giving some notations here. So you just write it down, and certain amount is taken to the sludge digestion. That is, it is wasted. So it is a waste sludge to treatment, and certain amount is recycled as we have discussed. So this is recycled and the concentration is XU. Even certain amount is directly taken outside as an effluent. So this is QE. This is concentration, that is BOD concentration YE, and XE. Okay, so this E stands for effluent, that means which is taken out, and this I stands for influent, which is going inside the activated sludge process. Okay, so now with these all notations we will be able to calculate the various formulas that have been given in this chapter. So I will give the formulas in the next video. So in this video you just write one more important point here. So what is the requirement of aeration? So aeration is required for two things. It is used for mixing and it is used for aerobic reaction. Aerobic reaction, that means what is the use of aeration tank? Mixing of, so what we are mixing here, we are mixing sewage plus activated sludge. Okay, and aerobic reaction. About aerobic reactions we have seen. One thing you write it down about aerobic reaction. So this aerobic reaction occurs in two phases. In phase number one, organic matter plus organic matter, or we can say organic matter is decomposed. Into biomass or sludge. And phase 2, you just remember this name, phase 2, there is an endogenous respiration. So what happens in endogenous respiration? So microorganisms start eating, or we can say start consuming their own cells. This you can also call it as death phase. That is the last phase in which the microorganism starts getting degraded. So that is called as an endogenous respiration. Okay, endogenous respiration. So this is all the concepts which are required for the activated sludge process. See, no need to go in much detail. You don't have to do PhD in this. Whatever things are important exam point of view, I have given everything here, all the important points. In the next video we will be seeing the formulas which are required, and based on that formulas only the questions will be asked mostly. Okay,